How much energy in joules per mole does the first step of the solar nuclear fusion produce? So you're given the equation, and then you're also given the mass of everything. So the question is asking for energy, but by Einstein's E equals mc squared, energy and mass are related. So we should start this question by calculating the change in the mass, since those are the values that were given. So to find the change in mass, what we call the mass defect, you can calculate the mass of the products and subtract from it the mass of the reactants. So the products are on this side, right? So we can just take that, 2.01401 AMU plus 0.00549 AMU. Oops, there should be another 0 in there, apologies. Now the mass of that positron is negligible, so you can include it or not include it, it's up to you, but you will get the same answer either way. We're going to subtract from that the mass of the reactants. Now there's 2 of these, so you could add those 2 numbers together, or you can multiply by 2, whatever works for you. And then if you add those up, subtract it out, you get a mass of negative 0.001321 AMU. And this is accurate only to this place, if you look at the signals. Okay, so that's the mass defect. We should ask ourselves, does this make sense? It does make sense because it's negative, and the question says it's producing energy. If it's producing energy, it means the reaction itself is losing energy. So if it's losing energy, it should also be losing mass. So that negative sign makes sense. Okay, so now that we have the mass defect, we can calculate the energy. We have the mass defect in AMU, but if you remember way back to Chem 1, an AMU is the same value in grams per mole. So you can just change the units from AMU directly to grams per mole and keep the number the same. So this, grams per mole, is a better unit because joules are related to grams, so that'll make it easier to convert to energy. Then we want to look at the relationship between energy and mass. It's related here. Energy is measured in joules. And it's important to remember that joules are in SI units, kilograms, meters squared per second squared. So if we want to calculate this in joules, that means that we need our mass in kilograms and our speed of light in meters per second. So we've calculated our joules in grams, and now we need to convert that into kilograms. We can divide by grams, multiply by kilograms. There's 1,000 grams in a kilogram. If we write that in scientific notation, that will be 1.1321 times 10 to the negative 6 kilograms per mole. And then the speed of light is a constant, 3 times 10 to the 8th meters per second. You can find that on your reference sheet. And then because this is squared, we will also square this. So when you multiply that out, you get negative 1.19 times 10 to the 11 kilograms meters squared per second squared moles. Then we know that kilograms meters squared per second squared is the same thing as a joule, so we can rewrite that as negative 1.19 times 10 to the 11 joules per mole. We can round this for sig figs. This was accurate to here. This only has 2, so 3 and 2. We can round it to negative 1.2 times 10 to the 11 joules per